Hey everyone, welcome back. We're going to look at one more example of a sampling distribution of a sample proportion. So in this problem, we are given that medical researchers think 0.7 is the proportion of all teenagers with high blood pressure whose blood pressure would decrease if they took a calcium supplement. To test this theory, the researchers plan a clinical trial or experiment in which 200 random teenagers with high blood pressure will take regular calcium supplements. Assume 0.70 is actually the population proportion that would experience a decrease in blood pressure. So it wants us to find the probability of having between 120 to 150 patients experience a decrease in blood pressure out of a sample of 200 teenagers taking calcium supplements. So this is kind of what a lot of problems and stats look like, right? There's quite a bit of info and you've got to kind of pick, not really pick and choose, but you've got to figure out what you need from the information they give you to answer the problem. So what we know we need, right, to solve a question about proportions, right? The proportions aren't directly given to us, right? But they want to know what's the probability between 120, basically out of 200, right? So that's going to be one proportion, right? 120 people experience a decrease in blood pressure to 150, right? Our second p hat. So basically, the x in our p hat or our p, right? This equals the number of teenagers, right? Technically, who experience, right, or who get a decrease, just going to draw a down arrow, in blood pressure from taking this calcium supplement, right? And what are we given? Where did I get that also from this problem? Right, so 0.70 is the proportion of all teenagers who have high blood pressure whose blood pressure would decrease, right, if they took this calcium supplement. So if you have high blood pressure, so it's teens technically with high blood pressure already, who would get a decrease in their blood pressure if they took this calcium supplement. So that's a categorical variable, right? It's either yes or no. If you take this calcium supplement, your blood pressure either goes down, right? That's a yes. What's the other option? It either stays the same or it would could potentially increase, right? So it's either yes or no, right? So it's a categorical variable. We're given the population proportion, right? We're kind of given it up here, but it's restated down here, right? A little more strongly. Up here, it just says they think that it's 70% or 0.70, but then in the problem, we're also told to assume the population proportion, right? There's that population proportion is equal to 0.70. So we're given that from the problem. And then what else are we given? We're told that to test the theory, the researchers plan a clinical trial or an experiment in which 200 random teenagers, right, will take calcium supplements. So the word sample isn't really in here, right? But from this sentence, we can kind of tell that our sample size n is equal to 200. right? Which we've also kind of assumed already down here. And we are also asked about it here as well. So what should we do to solve this problem? Well, we know that the average, right, of all of our sample proportions is going to be equal to the population proportion, right? So we know our normal distribution will be centered at 0.70, right? That's its average. And we need to calculate the standard deviation of our p hat. What's this going to be equal to? It's going to be equal to 0.7 times 1 minus 0.7 divided by our sample size, right, of 200. So this is going to be 0.7 times 0.3 divided by 200. Don't forget about that square root. So 0.7 times 0.3 is going to be 0.021. Oh, just 0.21, not 0.021. Sorry about that. So if we do that division, divide 0.21 divide by 200, you get 0.00105. But then we need to take the square root of that, right? Can't forget about that. And we get 0.0324, so we'll just leave it at 0.032. So now as we go up and down our standard deviations, we get, adding 0.032, we get 0.732, right? And then this would be 0.764. Finally, we get 0.796. Let's double check myself there. Yep, so then if we subtract 0.032, we get 0.668. Subtract another 0.032, 0.636. And lastly, subtract another 0.032, we get 0.604. So the problem asks us, right, what's the probability of having between 120 to 150 patients experience a decrease of blood pressure, which is that trait we're looking for, right? So that's why I put the 120 and the 150 in our numerators, right, out of the sample of 200. That's how we've built our distribution, right? So these are sample proportions where the sample size is always equal to 200. So if we just find the actual decimal values, if we do 120 divided by 200, that gives us 0.6, and 150 divided by 200 gives us 0.75. Great, so these are the proportions that we're looking for. It's the interval, right, of proportions specifically, 0.75. So 0.60 is somewhere down here, just below 0.604, right? Here's our 0.60. And 0.75 looks like it might be somewhere right around here, right? Less than 0.764, but greater than 0.732. And so we're looking for all of this area under our curve in between that interval. And we know that these sample proportions are normally distributed, right? So we can use our calculator to solve for this, right? We just need to remember the standard deviation of our p hat that mean and our two values, right? Kind of a lot to remember. So if I go back to our calculator, we can go to second vars, can go back to option 2, right? Our normal CDF, because we're looking for that area under the curve. And that interval we were looking for, right, was between 0.60 and our upper was 0.75. Our mean itself was 0.70, not 0.79, so I'll just update that. And our standard deviation, let me recalculate that real quick myself. I don't remember. 0.7 times 0.3 divided by 200. And the square root was 0.032. Okay, so we've plugged everything in and we get an answer of 0.94 or 94%. And this would be the answer to our question. 0.94 or 94%. Easy as that.